Hi everyone, my name is Benjamin, and in today's video I will introduce you to the x402 standard, which enables any API or web service to require payment before serving content. So we are going to cover what the x402 standard is, what specifications and use cases it has, and eventually we will build our own simple client and server setup to facilitate a transaction over x402. And on top of that, all the code will be available for download via our GitHub repository. For more information, you can always check out our official documentation or join our great Discord community. Both links will be in the description, and with that said, let's get started. Alright, so x402 is a open, internet-native payment protocol built on top of the HTTP 402 status code, and it is developed by the Coinbase development platform team. So what does that mean? Now, you might be familiar with the regular status codes when you are consuming an API, like for example error 500 or 404 page not found, but now we also have a error code which is 402, which stands for payment is required. Now let me explain with a small example. Let's say you run a service that provides the latest trending tokens, and in a traditional way users would subscribe to your service. They would pay, for example, $19 a month. You would give them an API key, and then they can request these trending tokens anytime they want using that key. Now, if we would use x402, instead of charging our users a flat monthly fee to access these tokens, you can charge them a tiny amount every single time they try to fetch these latest trending tokens. So rather than paying $19 a month, we can do something like 20 cents every time they make an API call to our backend service. Now this way it's more of a pay-as-you-go service, which is less of a hurdle for many users, and we as the service owners, we don't have to deal with maintaining subscriptions and API keys. Now, this is of course a small example, and the x402 standard has tons of use cases, including AI agent transactions, and we can also expose additional API endpoints behind an x402 payment wall. Now, by using this monetization model, every request that has been sent to our API to, for example, get these trending tokens needs to be validated as paid. And this is why blockchains are a perfect fit as the settlement layer for these x402 payments. And for sure, Solana, which is a high-performance blockchain with super low transaction fees, which makes it a perfect fit for both apps consuming our APIs or AI agents making multiple requests per second to access that premium content. Now, in other words, x402 will be the rails that these AI agents will use to facilitate their AI payments, and we will use the blockchain technology such as Solana as a blockchain for all our high-speed payment ledger logic. Now, I believe that x402 really kicked off with a focus on blockchain when Coinbase announced x402 earlier last year as a new way to facilitate these payments. And also, they provided users and developers with a client and server SDK, which we can use to implement this really easy with Coinbase as a facilitator. Now, after that, companies like Google and also many others, they started announcing agentic payment solutions, often relying on x402 technology. Now, with the rise of technologies such as MCP and specific tools like, for example, OpenClaw, agents and AI in general will pay for services, fund their compute, manage subscriptions, and take action on behalf of their users in an increasingly independent fashion. Alright, so now that we know what x402 is, let's have a quick look on how it's technically implemented, and after that we are going to build our own simple client and server setup to facilitate a transaction over x402. So here we have a diagram, and as you can see, a client, which can be an AI agent or a app, and that client will send a request to a API. Now this API will reply with a 402 status code, which means that a payment is required. Now there are different implementations, and based on that the client will select a payment method and once again query that same API endpoint Only this time it will add a X payment header. Next, the server will receive that request, verify that request with the facilitator, which will in turn send that transaction to the blockchain. Now, once it is confirmed, it will settle that request and finally return the premium content, including the payment response. Now, notice that we do not sign and send our transaction to the blockchain and then send a signature as a payment proof. We send a base 64 payload to that API endpoint, which includes a transaction, which is signed by us, but it's not submitted. And it is the job of the facilitator to make sure that this is a valid transaction, submit it to the blockchain, and once it was successful, it will return that payload, including the premium content. Alright, so now that we know what it means to be a client, a server, and a facilitator, let's create a small example where we will use Coinbase as a facilitator and also a Solana native implementation where we will facilitate ourselves. So with that said, let's jump straight into our code base. Alright, so this is our code base for today. And as you can see, we have two types of implementation. We have the Coinbase implementation, which is a facilitator where we use Coinbase, and then we have a custom Sol implementation where we will do the facilitating ourselves using Solana Kit. Now, if it comes to structure and code, they look quite similar and a lot of the logic will be repurposed. However, the Coinbase implementation is a bit more simple as the facilitating is done via their SDK, and for the other one, we are doing the facilitating ourselves. That's also the reason why we will start with the custom implementation, because then the Coinbase implementation will make more sense. So all the code is also available via our GitHub repository, and you can download that via the link in the description. So once again, if we look at that overview, we have a client, a server, and a facilitator. And that's why we are going to have a client file and a server file or a server app, which will also take care of the facilitator. And that server logic is stored under the server folder here, as you can see, and the index.ts file, that is actually our client, because once we run this, this will do that request to our API. Because if we look back at that diagram, this server is nothing more than an API that responds to a client that makes requests. And of course, these responses can be 402 and they can also be 200 if the payment information is provided. So that's what you have to remember. This server components, it's nothing more than an API. And that's also what we see here. So under server, we have a file called app.ts. And if we click on that, this is just a regular Express setup. So we're creating an API that our client later can consume. So if we go through this file real quick, what you can see here at the bottom, we are initiating the init server, and that initiates this function here. And of course, if there is an error, we are going to also output that there. And we also have some logic here to gracefully stop our API from running. So once again, init server is initiated, it calls this function here, and what it does is just creating a regular Express instance, and we are also setting a port, and our Express instance is going to run at port 3000. Now, all these variables are also stored under the environment file. As you can see here, we have a service wallet, and this is the wallet where we are going to receive the payment from the user. Remember, x402, we need to pay someone before we can get that content, and we're going to pay this wallet. So this is just a regular Solana wallet. This is the amount of lamp ports that we want to receive, and this is where the service will run. Remember, this is the API premium endpoint, and we are going to spin up that API on our local host, of course. However, this can also run on any API on the web. As long as we know where the service lives, we can access that. Now, the API endpoint that we're going to query, which is a premium endpoint, which will require payment, is /API/premium. And then we also have our RPC endpoint and the cluster that we're going to use and the port for the servers. So we're going to do this on DevNet for now as an example. So back to our instance, as you can see here, we create that Express instance. We're setting up some middleware to make sure that the limit from our request is a certain size, that our URLs are encoded properly, and then we set up a default route, which is the start route, where we can just check if the actual server is up and running. Furthermore, we have additional routes under /API, and the additional routes, they are stored in router, and we're going to look at that in a minute. We use some error handling middleware as well. And eventually we are going to start this server up by binding that port that we set up earlier here. And then it's going to start listening. And once it starts listening, we're also going to output a message like, hey, our server is now listening. This is the receiver. Remember that address that's going to receive the Solana. And these are the endpoints that are available. And of course, we have the actual server at localhost 3000. The default route, remember, where we can check the health. And then we also have a free endpoint, which we can query without any problem, and that will return to us content. And we have the premium route, which we can query as well, but there we have to provide that payment information. And if we don't do that, a x402 error or status code will be returned to us. And it also says here how we can actually test that. So this is just the basic setup. Remember, it's just an Express installation. And furthermore, we have these API routes here. So if we click on the router, this will open our actual routes. As you can see here under routes, we have two routes. And this is the free one. Again, this is just going to return us free content. And we have the premium one. And this is going to return us premium content. And the only difference, as you can see here, we have a middleware in between, which is called payment route. Now, let's first look at these controllers here, and they are stored under controllers. And of course, once we return free content, we are going to return one token, and we're going to use the same example as before. We are a token service, so we are going to return a free token. If they access our premium, then we are going to return 2 tokens. And of course, this is an example. In a production environment, you will return premium tokens, trending tokens. For now, we are just going to return 2 different types of payloads, a single token trump and 2 different tokens with and bonk, and these are our premium tokens. So this is our controller logic, and this is called by our routes here. So when we access free, we return the free tokens. When we access premium, we return the premium tokens. And only here we have that payment route middleware. And if we click on that, we go to middleware, as you can see here. And then under payment route, that is where our request will go through to check if we actually provided that x402 header. And that is what we do here. So the moment if that request comes through, we're going to see if a x payment header is set. And if it is not set, what we are going to do is just return a message immediately like, hey, the request is missing a x payment header, and it is responding with the details that we want to provide to our client or our AI agent in order so that they can continue with the actual payment. And as you can see here, we provide a recipient, an amount, and the cluster. And remember, these values, they are stored in our environment file here. So we have the service wallet, the amount of LAMP ports, and the service URL. So back to our middleware, that is what we return here. And I can show you how that looks like. First of all, let's query this endpoint without a X payment header, and then we are going to get back that information on how we can proceed with the payment. And then later on, we are going to look at our client to make that payment, and then we're coming back to this logic to see how we can validate it if it's a valid payment. So what we can do now is open our terminal. And as you can see, I have 2 terminals here. We have to go into the actual implementation from the custom sol. So that's where we are now. We can clear that terminal. And what we can do is npm run start server, just like this. And this will start our server. As you can see, this is the message that we are putting in the console. So starting the server, this is the receiver, just as I showed you before. And these are the endpoints that are available. And later we can use that start client function to test that actual x402 setup. Now, first, to demonstrate how it looks without that X payment header, what we are going to do here is just query this API/premium endpoint, and we're not going to provide a header or a payment header. We're just going to query this endpoint. And if we send that request, what you can see here is that we get back that 402 payment required. And that is actually what we want because we didn't provide any payment information. And also here we can see the payment that needs to happen to the recipient. So this address here, this amount of sol, and we want to receive it on definite. So now we know, or we got back these instructions to provide a payment response in the form of that X payment header, which actually satisfies this payment request here. So as you can see, now we just query the API endpoint, the premium, and we get back that 402. Now, if we are going to query the free one that we can also do, now you can see that we get back these tokens in the form of a 201 or a 200, which means that everything went well. And this is the similar response that we want to get back, but we want to get that back when we actually query premium. And that is what we are going to look at now, because for now we are not providing that actual payment information. So back to our code, we know now that our payment route is working properly because we didn't provide that payment information or that X payment header, and that is why we return this information here, just as we saw in Postman. So before we proceed with this logic, in order to check the actual payment information that has been provided via the x402 header, let's look at the actual client where we will do the request, including that payment information. So that is all stored in the index.ts file. Now, as you can see, the first thing that we do here is also import all this information like the service URL, the price, the service wallet, also our RPC endpoint and the cluster. And we're also going to create a key pair. Remember, someone needs to pay for this premium content, and that is the key pair that we are going to create here. Now, if you check out the wallet file, here you can see a id.json file, and this is just a private key that we will use to derive a key pair from, that we're going to use to create a transaction, sign it, and then send that transaction via that base64 header. Remember, if we look back at this, we're going to create that payload here in the form of this base64 and then send it with that header. However, remember, we are not going to send that transaction to the blockchain. We're just going to create a transaction, sign it, and then we're going to send that transaction to our facilitator, and that will handle it for us further. So that's what we are doing here. So if we scroll down, you can see that we initialize our wallet first. We're just taking that file, that id.json file, which holds our private key, and then we are going to actually derive a new key pair from that using, as you can see here, it's all imported via Solana Kit. And then we are going to return a key pair. And then we can use this key pair in the remainder of our function to actually create that transaction and sign it. Now, once this was successful, as you can see here, we are going to trigger the init payment. And here is where we are going to create that payment that we can send, or the payment proof, or the transaction that the facilitator can handle with our next request. If we trigger this file, it will just output like, hey, this is the wallet that we're going to pay with, the shop, which is the service URL. And the next thing that we do here is create a RPC instance. And for that, we use create Solana RPC, which also comes with Solana Kit. So here we are just going to create a simple RPC connection that we can use further along. So the first thing that we do here then is get the latest block hash, because also that needs to be part of our transaction. And then we are going to create a transfer Solana instruction. And here we can also use the function get transfer sol instruction. And this is imported via the Solana program system. Now this will just create that instruction, and then we can use pipe here to create a empty transaction message. We're using the legacy version for now. We're going to set the signers, which is our key pair once again that we created earlier. We're going to set the latest block hash, the one that we got here via the RPC call that we made. And eventually we are going to append our message instructions. And for now we only have one, which is that transfer instruction here to send that sol from our key pair, remember, to the destination, and that is the service wallet. So what we're going to do is send a amount of sol from our wallet to that receiver here, so to the service wallet. So that's what we do here. Back to our index, that's what we do here. As you can see, the source, the destination, and the amount. And then we have a transaction message, and that transaction message we are going to sign, and for that we use the sign transaction message with signers. And then we have a signed transaction. We are going to encode it so that we can send it properly, and for that we use a function get base64 encoded wire transaction. Now once we have that, we are going to create a object with the payment proof, and this is just a set object. And here we specify the x402 version, the schema, what network we're using, and the payload. And here we are providing a serialized transaction, and that is what we created here. So this transaction we are going to send in the form of this object. So now we have the payment proof. The next thing that we are going to do is create a buffered header, and that's what we do here by using buffer from and then that payment proof, and we're going to buffer that into base 64, and then we have that header which we can actually send to our endpoint, and that's what we do here. We are using Axios, which is just a fancy fetch module or a library. We're providing that service URL. Remember, the service URL we got from our environment file, and if you look back at the environment file, the service URL is just that premium endpoint. So back to our index file, if we look here now, Axios is going to send that GET request to this premium content URL, and this time we're actually providing that X payment header. Remember, that header that we just created here, that includes our transaction, which is not sent to the blockchain. It is signed, so our facilitator can receive that transaction and then send it in turn to the blockchain. Now, once that is done, we're also going to output the response, because if everything went well, we provided that payment proof and we should get back these premium tokens. So that's what we are going to check now. So once again, we can open our terminal, new terminal, and here we can clear our terminal and we can run it once again. So we know that our server is now up and running. If we open Postman, we can send that request once again. We get a 402. And then of course, we also have to go into the custom Sol facilitator map like this. And then we can type npm run start client like this. And this time it will send that same request. And as you can see, now we got that response back, but now we have the premium tokens, the WIF and the bonk token. And before we didn't get that. And also here we can see that we received a potential payment from the network, the schema, the version, and also the transaction. And as you can see, we log it out here. That is that transaction. So if we do this a bit down, this transaction, the serialized transaction, that is what we see here. As you can see, transaction, this is what we actually sent and what our facilitator uses to validate that payment proof. And if it is validated, it will send it to the blockchain, and once confirmed, it will serve us that premium content. And that is what you see here. Now we received that premium content. So we know that our implementation works, that our client does what it should do. So what we can do now is go back to that actual controller, I believe, or the middleware better, and check out what we are doing here in order to validate that header that has been sent to us. So as before, we get that request, remember, and we check if we received that x402 header. Now this time we received that header, so we're not going to return that 402 response, but we are going to take that header and validate if it contains a valid transaction or payment proof. Now, what we do here is first extract this from the schema that was sent to us, and we output the information from that header. Next, we are going to take that payload, because that is really interesting for us, that serialized transaction that contains that signed transaction from our potential customer. And then we are going to take that transaction, we are going to decode that using the get transaction decoder. Then we are going to get the compiled transaction message decoder, and then we are going to decompile that transaction message. Now you can look at this. This is all imported via Solana kit, and this is actually the reverse that we do from building that transaction. Now we are going to decode that transaction. So once again, once we have this transaction message, we are going to do some basic inspection. And just to make it a bit more clear, what I can do here is console log that transaction. So let's do that here. So that transaction that we're going to receive, we can open this once again, clear our terminal. If we run this now, as you can see, start client. Now we're going to output that here. If I believe we need to maybe restart the server as well. So let's do that. So if we clear the terminal here as well, and then restart the server, and then send that transaction once again. Now you can see I output these instructions here, and you can see it contains one instruction, which is a transfer, because we see that based on this program address, the accounts are also included, the data, and of course the version, the fee payer. So this is the transaction that we're interested in, and that we now want to verify if it is a valid transaction. And that's what we do here next. So we look at that transfer instruction. So I can remove that console log. We check that transfer instruction if it's a actual transfer by looking at the program address. If it's not, then we're going to output a message like, hey, it's an invalid transaction, so you don't get served the premium content. We're also going to check if this transfer instruction has more than 2 accounts, because a transfer instruction often is just a transfer from one wallet to another. So if there are more wallets involved, we're not going to proceed. And again, it's an invalid transaction and too many accounts in the instruction are found. So it seems a bit strange. Remember, this transaction is not sent to the blockchain. So no money is actually taken until it is sent and confirmed. So if this is rejected, that's fine. The user doesn't get the content served, but we also didn't take the actual money, or we didn't do the actual transfer until we confirmed that this is a valid transaction. Now, what we do next here is check if the receiver address from that transaction is actually our service wallet. And if not the case, then we will also return a 400 message that it is an invalid transaction because no transfer to the service wallet was found. Now, next we are going to see if the actual transfer is the right amount of LAMP ports, and that we can do by get the buffer from the data, and then we are going to check that buffer for a certain offset, and then that offset will return to us the amount. Now, if that amount is not the same as the actual price that we set in our environment file, also then we are going to return a 400 saying invalid transaction, it's an incorrect payment amount. Now, once this is all good, what we are going to do is create here also a Solana RPC connection using our RPC endpoint. This is now on DevNet. And then we are going to send that transaction, that serialized transaction, using that RPC connection, which exposes a method called sendTransaction. And once we get that signature, we're also going to return that or output that. And that's also what you can see here. So once we get that signature, we output that here, and we can look at that in a minute. If this is all good, we're just going to tell our middleware to move on and serve that content. Because remember, this is just a middleware called payment route that is used by our root here. And once this is good and tells us you can proceed, it will serve that premium content. So once again, what we can do is stop this. We can start that server again, and once again, send that transaction. And then here you can see that we get a signature back. And let's have a look at that signature real quick. Now, I opened SolScan, as you can see here, and we need to make sure to change to DevNet. And then we can enter that signature here that we copied. Then we can actually see what happens. So here you can see that we do a transfer from that pay wallet. So this is the wallet that we derived from that private key to the SVS wallet. And remember, if we look at our code base to the environment file, you can see here that is the wallet that we sent to. It starts with SVS. And that is what we do here. So we transfer that 0.001 Sol from this wallet to this wallet. And you can see it is success. So this is the custom Sol implementation, and it all comes down to responding with that 402 error code like, hey, you can get this premium content once you provide valid payment proof. Now, payment proof in this case is not an actual payment. We are going to send a transaction that is signed by us, and that allows the facilitator to send that transaction to the blockchain, and once it is confirmed, to serve us that premium content. Of course, as the facilitator, you also want to make sure that the transaction or the payload that has been sent to you is valid. Because if a transaction is sent to you and you just check, hey, okay, I received the transaction, here is that content, you see that there is room for error, or people can send bad transactions or duplicate transactions. So we always want to check this transaction, see if the amount is correct, that the receiver wallet is correct, that the right amount of accounts are there, that the transfer program is actually in that transaction. And if this is all good and we can send it and it can be confirmed back to us, only then we are going to serve that premium content. So this is how we set up a custom implementation, and now we're going to look at the Coinbase implementation, which is quite similar. However, the facilitating is all done by Coinbase via their SDK. Alright, so now we can also have a look at the Coinbase facilitator example. Also, I opened two terminals here. and I made sure that I navigated to the Coinbase facilitator folder. Now, as you can see here, we have the same structure. So also that source folder and then a server folder. And we have that index file, which is our client, and then of course the wallet. Now, if we look at the server first, this is also a Express installation. Same thing as before, same port number. We do the exact same thing. We have also our API route, and there we have our router and the main route. So under router, we also have these routes, the free one and the premium. And we also have the controllers, and these are actually providing us that content. So the free content and the premium content. So this is all the same as our previous setup for the custom facilitator. Now under middleware, as you can see here, for our routes, we also have that payment route middleware. Remember? Here our request goes through, and then in the previous implementation, we actually validated that request or that payload from that request to see if the payment was actually valid, if the transaction that we created and signed was actually a valid transaction. Now we have to do similar logic. However, this time we are going to use the Coinbase SDK to facilitate that for us. And for that, we also have a middleware called payment route. Again, we take the same approach as before. So under our middleware, we have that middleware function here called payment route. But the first change that you will see is that this is using payment middleware. And if we go to our imports, you can see that we import that via the x402 Express library. Now, as you can see, what we do here, before we had that whole logic. So if we look at the earlier implementation, so if we go back to our Sol implementation under source, server, middleware, index, that payment route. So this is all the logic that we had to get that X payment header, then extract that actual transaction, look into that transaction, do all these checks here, as you can see, and if they were not valid, then we will return that 400, and eventually we had to send that to the blockchain, and then if it was all good, we returned that premium content. Now, if you compare this to the payment routes that we have for the Coinbase implementation, you can see that we wrap that in this function here, payment middleware. Again, it comes from that x402 Express library. And what we provide here is just the actual route, so the get premium route. We set the price, which is of course in dollars this time, because we are using USDC. So if we go back to our environment file, what we have here is the receiver. The price this time is $1, and we also have a description. But other than that, we also have that port here. Back to that file, back to that route better. Here, that payment middleware. What we do here is set the price, the network, once again, Solana DevNet, and we also provide a description. Now, this is the only thing that we need. So if we start our server here now, we can use the same command. So we can do npm run start server like this. This will also start our server now once again. And also here you can see it says starting server, the receiver, and we also have the same endpoints, the free, premium, and the main one that we can use to check the health. So let's do that once again. So you can see here we are not changing anything. We use the same endpoint. If we try to access that premium content now, you will see that we get also that 402 payment required. And also here we get back all the information that is needed. Now here you can see that it accepts on the network Solana DevNet, the amount that it accepts, and then also some other information like who we have to pay to. So it's a bit more information than what we initially returned with our own implementation. But again, the most important thing is that it returns that 402 payment required and what payment it actually accepts. Now here also we can query the free one, and here we get that token back, just as before. So let's have a look at the actual index file here as well. This is also our client that will request the premium content from that premium route, and we are going to do the same approach. So here again, we are going to initialize our wallet just as before, and after that we are going to initialize the payment. So once the wallet is set up properly, and also here we derive that from that private key that we have stored here under wallet, just as we did before, and then we initialize our payment. Also here we are going to output that we are going to do that, the wallet that will be the payer, and the shop. So this is the service URL, so the premium endpoint. Now what we do here is set up a Axios 402 client. And what this does is just setting up a Axios client. And this is just a wrapper around Axios, I believe. And this is also a library from Coinbase that will help us with accessing that premium x402 endpoint. Now, what we do here is just creating a Axios instance. And Axios, once again, it's a fancy fetch library. We create a instance. The base URL is once again the service or the premium endpoint that we want to reach. We provide our key pair, and then that function with payment interceptor will create that Axios 402 client. Now, what we can do now is just use that client to access a certain endpoint. As you can see here, we're going to access via a GET request that default endpoint. So what this will do is just log out that message that our server is up and running. Now, the next thing that we're going to do here is send a GET request once again, and this time we are going to access that premium route, as you can see here. Now, the good thing is, if we create this Axios 402 client, and if you hover that, you can see exactly what it does. So it extracts the payment requirements from the response. So that response that we get here, now this function, as you can see here, it extracts that information or these requirements. It then creates that payment header using the provided wallet client. Remember, we also initialized our own wallet, just as we did before, and we also provided that here once we created an Axios 402 client. Now, the next thing that it will do is retries the original request, and this time it adds that payment header. And then it exposes the X payment response. So this whole client that we created here will take care of everything for us. So it queries the premium content endpoint. It gets back that response. It checks out how it can pay. It creates that payment header for us. And it retries that same request with the payment header attached. And that is what this client does, that we created here using that with payment interceptor from the library that we imported here called x402 Axios. Now, once we get that response, we are going to check if we got that X payment response. If we look back at the actual diagram, this is what we receive here. Eventually, once the facilitator, which is now Coinbase for us, is satisfied, it will return to us that premium content, including the X payment response header. And that is what we look for here. So if we got that response header, then we're going to decode that response header. And once again, also this is less logic than what we had in our earlier own implementation. And this is also imported via this library x402 Axios. It decodes that, and then we have the decoded response. And from that decoded response, we can just extract the transaction. And then we can use that transaction to inspect it. Now, of course, if anything goes wrong and we got some kind of error, we will also catch it and output that here. So this, as you can see here as well, the logic is also simplified. We don't have to create these instructions, append it to a transaction, then make sure we have the latest block hash, make sure that transaction is in a proper format, and then we also have to make sure that all this information is within a certain object, and then that object also need to be encoded, and then we can send that via the header. As you can see, all that logic that we did here before is now handled by this library that we imported here by using the with payment interceptor and the decode payment response. And that is all we need to do to use Coinbase as a facilitator. So once again, our server is still running. We can also type here npm run start client, as you can see here. And also here it says accessing premium content. And also here we get back that premium content. And also here we have that transaction. So if we copy that and then go to the Sol scan once again and search for that transaction. Also here you can see 54 seconds ago, we transferred 1 USDC from our payment wallet to the SVS wallet. And once again, this time you can see we used USDC. Under the hood, we had a Solana address. So we need to make sure that our Solana address has some USDC in it. And of course, the receiver wallet as well. I think it creates the associated token accounts by default if the receiver wallet has none. However, I made sure that both of these wallets has some USD in it, and then we can transfer USDC from one to the other. As you can see, the implementation with the Coinbase facilitator is much easier to actually create than when we do our own custom implementation using native Sol. However, there is always trade-offs when you use a different facilitator or a third-party facilitator. This is because you're not really in control of everything, and there might be downtimes, there might be other things that prevent you from receiving payments. So if you want to control the whole flow, both the server side and the facilitator, you can choose for something like the custom Sol facilitator. And if you want to have a more simplified implementation, then you can always go for the Coinbase facilitator. Now, real quick, you can always go to the official developers documentation, and there it says how to get started with x402. And it also explains a bit what it is. You have that same diagram here. But if you scroll down a bit, you will see that there are many different implementations. And we looked at the native example right now, and I believe at the Coinbase example here. But you can see there are many more projects and SDKs, so you can go through this and see which implementation actually fits best for you. Again, as a reminder, if you want to have a quick example that you can just download and run straight away, you can find it on our Git, and the link for that is in the description. Alright, so with that said, I hope you now understand what x402 is, what use cases it has, what possibilities it has, and how you can implement it yourself natively or using an SDK. So I hope you think it was interesting, and I hope to see you in the next one.